Hello guys, welcome to my YouTube channel Chem Discussion. From today, in every week I will upload a Q&A series, that is question answer series for NIPER JEE and GPAT aspirants, and this is the part 1 video. So subscribe the channel and press the notification button to get more updates from this channel. And this question answer series will be very beneficial for those who are preparing for GPAT as well as NIPER JEE. So let's start. The first questions is asked that which one of these 4 substrate will not give Diels-Alder reaction. So before going to the discuss, one should know what is the Diels-Alder reaction. Diels-Alder reaction is the pericyclic reaction where the diene is reacting with an olefin under thermal condition to give a cyclic product. Here this system is 4 pi electron system and here 2 pi electron system. That's why this is called 4 plus 2 cycloaddition reaction. Cycloaddition reaction. The prerequisite condition of this reaction is the diene should be in cis geometry. That means the diene should be like that, not like that. But if it is in the acyclic form, then this single bond can rotate and it will give this type of diene. But if it is in cyclic structure, then this will not give cis structure and it will not participate in Diels-Alder reaction. So let's check. The first one, the diene is S trans. That means this will not participate in Diels-Alder reaction because first of all it is the S trans structure, and the second thing is it is in the cyclic structure also. So this will not give the cis structure or cis conformation. So this will not give Diels-Alder reaction. The first one will not give Diels-Alder reaction. Second one, although the diene is in the cyclic structure but it is in cis form, so this will give Diels-Alder reaction, and this will give Diels-Alder reaction also, and this one obviously give Diels-Alder reaction. Let's check another question. This is from Grignard reaction. We know that the Grignard reagent, when it reacts with ketone, it gives tertiary alcohol. When it reacts with acetaldehyde or aldehyde, it gives secondary alcohol. When it reacts with formaldehyde, this gives the primary alcohol. But what about the reaction between Grignard reagent and any ester? If we see this reaction, first Grignard reagent will attack this carbonyl carbon to give this tetrahedral intermediate. Now if you look this tetrahedral intermediate closely, you will see that there is a good leaving group. This is ethoxy group and it is a good leaving group. So this oxygen negative charge will come here and this ethoxy group will go out to give a ketone. But we know that ketone also reacts with Grignard reagent to give tertiary alcohol. So once again one molecule of Grignard reagent reacts with this ketone to give this tetrahedral intermediate, which on acidic hydrolysis gives this is methyl group, nothing but methyl group, gives tertiary alcohol. That means when Grignard reagent reacting with ester, two equivalent of Grignard reagent is required to get a completion of reaction, and when it is completed it will give a tertiary alcohol where the 2R or 2R substituent will be coming from the same Grignard reagent. So this is a very important type of reaction and may have the chance to come in GPAT as well as NIPER. Let's check another question. This is very simple. Pyridine is treated with hydrogen peroxide. When generally we perform different type of reaction on pyridine, first we convert the pyridine into pyridine N oxide by treating with hydrogen peroxide. So this question actually has been asked in GPAT 2018, and along when it is treated with pyridine, this will give pyridine N oxide. So it is an important reaction. Now let's see another question. The Walden inversion is the characteristic feature of the which of the following reaction? So here 4 reaction has been given, but we can easily see that inversion of configuration occurs in SN2. So let's see what type of things happens in SN2. Suppose there is a tertiary alcohol, secondary alcohol, and in presence of another nucleophile, when it attacks from this side, this will go out to give this product. So here if its configuration is R or S, this will be converted into R from S or S from R. So this inversion of the configuration is called Walden inversion. So the Walden inversion is the essential features of SN2 type of reaction. Let's see the next question. Radical cyclisation reaction is governed by which rule? This type of question may ask in NIPER JEE. So generally the radical cyclisation reaction is governed by Baldwin rule. According to Baldwin rule, the different type of pattern is given and which one is favorable, which one is not favorable, he experimentally derived. So the radical cyclization reaction is governed by Baldwin rule. Now let's see the next question. Name of this class of compound. This is a very important class of compound, and generally it is called N heterocycle carbene. Generally carbenes are very much reactive, but N heterocycle carbene is very much stable under normal room temperature, or you can actually easily isolate it. So this class of compound is very important, and such type of question actually came in NIPER JEE. So this is also an important question. Now let's see what is the name of this reaction. The name of this reaction is actually Birch reduction. Birch reduction, and also known as dissolving metal ammonia reaction. Here this lithium metal is dissolved into liquid ammonia, and then it transferred electron to this aromatic ring to reduce it into 1,4 diene compound. This is 1,4 diene compound, and this is a very famous reaction. And one time in NIPER JEE a question has been asked from this name reaction also. Now let's check the next question. This is a very important intermediate, and this substrate is called diazomethane. And when diazomethane decomposes under thermal condition, it gives carbene and nitrogen as a stable compound. So this is called carbene. So diazomethane under thermal condition decomposes into carbene intermediate, and this question may ask in GPAT as well as NIPER JEE. The next question is the selectivity of the acylation. We know that the electronegativity of the oxygen is much more than the nitrogen. So under a set of condition, for the oxygen it is difficult to act as a nucleophile, but the nitrogen may behave as a base as well as nucleophile. Here this nitrogen lone pair attack to this carbonyl group under basic condition, this is pyridine, to give N acylated product. This will go out as a leaving group. So what will be the structure of the product? The product structure will be very much like this. So this is a very important conceptual question and may come in GPAT. So let's see the next question. The next question is geometry of the intermediate present in SN1 reaction. So in SN1 reaction, what happens? First we should look at this. First, if this is a tertiary halide compound or different type of pseudo halide compound. This X may be chlorine, bromine, or triplet, mesylate. So this X is a good leaving group. Now under SN1 condition, this bond will be broken down and this will form a carbocation, and this carbocation is very much planar and sp2 hybridized, and the shape of this carbocation is triangular, and this angle between two bonds is very much near about 120 degree depending on the R substituent. So this is also an important question, and the right answer will be carbocation planar, not carbocation linear. So that's it for today. Thank you for watching. Subscribe my channel for getting more updates, and from today onwards every week I will try to upload a question answer series on basic organic chemistry for GPAT as well as NIPER JEE aspirant. Thank you for today.